Hi, I am Sarah, and this is Themis, the AI deliberation system I built for Sprint 2, and this is my messaging-rich system. So, the main idea behind Themis is the most AI tools give you one answer from one model. I wanted to build something more thoughtful than that. So instead of asking one AI for one response, Themis runs the Cancel of 5, specializes the AI advisors. Each advisor looks at the same question from a different perspective, and then the system brings those perspectives together into one final piece of counsel. The 5 advisors are Athelena, who focuses on emotional truth, Metis, who focuses on the pragmatism and trade-offs, and Mezzamine, who brings knowledge and context, Oracle, who looks for the long-term view, and then Iris, who acts as the challenger and the devil's advocate. So under the hood, Themis is built on several architecture patterns. It uses a publish subscribe message bus and content-based router and an aggregator and an explicit state machine and a replayable audit trail and a real embedded MQTT broker and a zero trust security. So I'm going to show you in two ways. First, the live app, and then in the code. All right, so I'm going to start with a real decision style prompt. This question is going to be about choosing between a startup job and an equity and lower paying versus staying with a stable job. It gives the council enough context to actually deliberate instead of just giving a generic answer. And I allowed my model to be able to ask me questions if it needs clarifying information. So it's asking how much lower is the startup salary compared to the current income. Current income, say 60,000, and then startup, let's say 40,000. And then they're allowed to ask follow-up questions if they have any. Let's say vesting schedule is 1% over 4 years. 1.25 every year. All right, so at the top, you can see that the system is moving through all the phases. So it was listening, convening, gathering, now they're deliberating. They're going to be weighing, and then the cancel is going to come together where we're going to synthesize and get our ended response. Now the advisors are responding as you see, one by one. And each advisor has its own independent agent. When the advisor finishes, it publishes its response onto the messaging bus, as you see here, and that publishes the subscribe pattern. The advisors does not need to know who is listening. It publishes the message, and the subscriber can react to it. So for example, the browser can show the response live, the audit trail can save important events, and the MQTT bridge can publish messages to the broker. That gives the system decoupling. So now you can see also that the advisors have distinct roles. So Athelena is looking at the emotional side of it. And then of the decision, Metis is going to be looking at the practical trade-offs. Mezzamine is going to be bringing the context. Oracle is thinking long-term, and Iris is challenging the group on purpose. Iris is important because her role is to stress tests and decisions instead of just agreeing with everyone. When the vote appears, as we see here, this is where the aggregator comes in, and the system has 5 separate votes, and the aggregator collapses them into one consensus direction. And then this is the final cancel. The synthesizer takes all 5 advisors' responses and vote and their original question, then weaves them into one balanced answer. So the final response is not just one model answering directly, it is the result of multiple perspectives of being gathered and compared, challenged, and synthesized. So if Themis asks a clarifying question for, say, like it did, what actually part of the design is in the context-based router deciding if the question is too vague or too deliberate on yet. So instead of just sending it straight to the council, it opens with a request reply as it did before, and then before the exchange first. So the answer then clarifies the question, and then we can just press enter and it goes through all of the synthesizing. All right, so what if we want to ask maybe a follow-up question? I built that in so that we can do that. And what if, and my question is, what if the startup is pre-revenue and could fold within a year? And then with that follow-up question, it's going to go through the same decision tree as it did before. So the full council reconvenes. It does not start from scratch though, and it is seeded with the previous question and the previous consensus as memory. So it builds on what it already said instead of just treating it like a brand new conversation. That makes this a real multi-turn deliberation. So over here, we can see our past councils list, and each past council gets a short AI generated title. So for example, I tested it with a little over 20,000 characters. It will synthesize, make a title to basically give just an easy brief overview of what that past council is talking about. And with this council's consensus, it looks like that I should stay in my current stable position. It doesn't think me moving to a different employer that does have equity in there would be a best suit for me in this circumstance. All right, so this is my EIP map. It lists the enterprise integration patterns I used and showed where each one lives in the code. So the main patterns I focused on were the publish subscribe channel, connect base router, the aggregator, the document message, request reply, and the contact enricher. So I'll walk through the main ones. So this is the publish subscribe channel. So this is the messaging bus that is centered off the system. The main idea is that the publish can reach many independent subscribe functions in a deliberation, and I wire up the subscribers to different jobs, and one subscriber sends messages to the browser. Another subscriber records the important messages to the audit database, and the MQQT bridge can also publish those messages out to the broker. So the publisher does not know who is listening. That is the main benefit of the publish subscribe. It decouples the system and connects the observer design pattern because the subscribers are observing events and reading when something's changing. All right, so this is my contact base router. Its job is to read the user's questions and decides whether the workflow should be taken. If the question is clear enough, it routes the question to deliberate. If not, then it will ask a question for maybe like missing important context, and it will route the question to clarify. So the route is based on the content of the message, not just the hard-coded button or endpoint. This is my aggregator. So the aggregator takes multiple votes and turns them into one clean consensus. In this case, Find Advisor votes in, and then the one final consensus comes out. I like this part because it's the pure function, and that makes it easy to read, easy to test, and easy to reason about. So this function sits in my main server file. So what this does is each advisor response votes council message is treated like a document message because it carries structured information as a self-contained message. So the clarification loop is a requested reply because the system asks a question and it waits for the user to respond. And when it follow-ups carries the previous council forward, so it works like a content enricher. So the new question gets enriched and the old council context before sent back through the workflow. This is my state machine. So this file defines the legal states and transactions for the council session. So we got our transition table for each state for only certain events are allowed. Then we got the send function, throws an error and the workflow tries to make an illegal move. That means that the system cannot get into the nonsense order. For example, it should not vote before the advisors have responded, and it should not synthesize the council before the perspectives have been gathered. So the state machine enforces that order, and it also is a non-trivial because it branches in loops as a listening, and it can either clarify or proceed. And if it clarifies, it can loop through the clarifying back to listening and the user's answers. So it's just not a straight line checklist, it's a controlled workflow. So this is my mermaid diagram showing that the same flow visually. So every state transition is also written in the audit trail as a themis/state message, and that means that the state chart itself is replayable and stored events. This connects to the state design pattern because the behavior of the workflow depends on the current state. This is my MQTT broker. So the internal message bus handles in-process messaging, but I wanted to go a little bit further and show the real network messaging. So Themis runs into an embedded QM broker as displayed here, and it uses the MQTT client inside the app. So every council message is published to the broker under a topic like Themis, session, topic, so forth. And then it monitors the subscribes to the Themis, and then the app is using the real publish broker subscribe flow. So this page shows that the MQTT bridge is live, and it can see the publish and observed contact counters, and then the council runs these counters and goes up because the messages are actually being published to the broker and then observed by the subscriber. So the real MQTT traffic is in production, not a mock. And because of the broker, it's embedded inside the app, and I did not need to pay for a separate MQQ service, which is great. And now let's go to the next slide. So this is my audit trail and persistence. So these are two main tables. So we got the events table, which is append only, and then that means that meaningful messages are added, but they are never changed in place. Then the sessions table also stores the summary information for the history list because the events are append only, and the reconstruct function can only replay any past deliberation step by step. So Themis does not only save the final answer, it saves the process produce the answer. That makes the system easier to debug and easier to explain and easier to recover. And this also echoes the memento pattern because the system can reconstruct a previous state stored history. I went and read the document that Anthropic released late last month, where it was talking about zero trust architecture. So to go that into a bit more cleanly, let's show you the code. So the last major place, like I said, was the zero trust idea, which means that the system never automatically trusts the inputs. So we always treat it like a security risk every time it comes to us. So there are several layers that we have to go through. So one is the WebSocket connection, and they are checked with the same origin. User input is cleaned with the clean input. Inputs are length capped, and then the rate limiting on the rate max. There is a max payload cap, and the app also sets a security headers, X-frame options, and non-sniff, and also uses the cache control no store. So sensitive responses are not cached. And these are their personas for each of my different council of 5. Users can text gets wrapped in the delimiters and labeled as data and not instructions. So that matters because the user can type anything, including something like ignore or your previous instructions, but Themis frames that text as data and the advisors to reason about, not as a command or the model should obey. So the system has security layers across transport, input handling, and the AI prompt surface. So to wrap up, Themis is a messaging-rich AI deliberating system. It uses 5 special AI advisory agents. It uses a publish subscribe messaging bus and to decouple the agents and browser audit trail and the MQTT bridge. It uses a context-based router to decide whether to clarify or deliberate. It uses an aggregator to turn 5 votes into 1 consensus. It uses a state machine to control the workflow. It has a replayable append-only audit trail, and it includes a real embedded MQTT broker. And it uses a zero trust security layers to handle each input more safely. Then the core idea is the 5 AI advisors deliberate on a message bus, and a state machine referees the workflow, and the system produces one final answer and also been challenged, balanced, and recorded. That is Themis. Thank you for watching.